Good morning, class.
Good
Good
morning,
morning,
Good
sir.
morning,
Good morning,
sir.
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 Yes.
Good morning.
Good morning, Sir Jet.
Good morning. So our very first discussion will be centered on Mr. Isaac Newton and his three laws of motion. As you can see here, the picture of Mr. Isaac Newton, who is quite famous in his field, which is science. And not only science, but he is also a good inventor, no? But for the time being, we are going to focus on him being a scientist and how he manages to develop the three laws of motion. Let me give you a sample first. Who gets to, um, if two of your classmates who is going to run, who would be the easiest to stop? Is it your classmate who weighs 100 kilograms? Or is it your classmate who weighs 50 kilograms? Who do you
50
think will be the,
kilograms.
Daniel is correct. The one which is going to be um, of a lower weight or has a lesser weight. So that is what we are going to focus on the first law generated by no other than Mr. Isaac Newton. No? The first law is the law of inertia. The
Inertia.
second law is the law of acceleration.
Acceleration.
And the third law is the law of interaction. Again, the first law is the law of inertia, which is located, I think, in the description here. The second law is the law of acceleration, though it's not pictured as the law of, but it's the law of acceleration. And then the third law is the law of interaction. What is the first law stands for? What do you think is the first law about? By the way, when you define force first, that there is a definition of force here on top. Force is any push or pull. Force is defined simply by the act of pushing or pulling. No? So for example, if you are going to be asked by your friend, go and 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 ride a bike. There's no force there. But if your classmate or your friend will push you, go and ride a bike, then force is already applied. But if only verbal command where there is no act of pushing or pulling, then there's no force applied. Perhaps the force is directed to the act of saying the phrase or the word, but in science, force is directed upon the action of pushing or pulling. Okay, so we have here the first law, and that's the law of, what do you think was the first law again? The law of,
Inertia.
very good, the law of inertia. So what is the law of inertia stands for? The first law under Newton's law of motion is often stated to as the as an object at rest stays at rest, an object in motion stays in motion unless there is an unbalanced force that acts on the body to for the object to stop from moving or from rest to move. So for example, may I ask those who are not muted to mute themselves so that it won't generate any feedback on my end? Okay, let's continue then. So imagine a certain ball placed that on the ground. It won't move at all. That is the first law all about. When an object in rest, it will stay at rest. Unless, what is that unbalanced force that allows the ball to move? If someone will push it, right? If someone will push it or grab it or kick it, then the ball will now move. So the law of inertia says that if the object is in at rest, it will stay at rest. With a velocity of zero and acceleration of zero, it will always stay at rest. However, an object in motion will stay in a uniform motion unless, again, if an unbalanced force will act on it. For example, you are going to roll the ball. Upon rolling the ball on the ground, flat surface, the ball will continue to roll to the direction you aim it unless the unbalanced force will act upon it and the ball will stop moving. So what do you think is that unbalanced force that allows the ball to stop from its rolling motion? Again, if you let the ball to roll in the ground, it will roll to the direction you aim it for. But if you look at it, at some point, the ball stops in its motion. Huh? So what do you think is that unbalanced force, that unbalanced action that allows the ball to stop from its rolling motion? Anyone? Daniel, yes, Daniel.
Friction.
Very good. Friction. Huh? For without friction, everyone in this world is going to slide upon. You yourselves will constantly slide to the floor. Your chairs and your tables will slide in your area. Your laptops will keep on moving without friction. But with friction, these tendencies are then being controlled. However, in a frictionless ground, an object in motion will always stay in motion. The unbalanced force there that acts upon that said rolling motion of the ball and stops it from its motion is the friction force of the ground and the rubber matting of the ball. So that is the law of inertia, the first law of motion. All of these are in your module, so you may not draw the definition as well. So we have here the definition of inertia, the resistance of an object to change in a state of motion. That's the definition of inertia. So it will resist the motion, moving motion or a steady motion. There's a picture here that will tell us the law of inertia is all about here. So this is a balance force. The person exerting force to the ground and then the ground exerts force to the person. No? At the same time, the person stands up to equate the gravitational force of the person of the ground that drags it downwards. So there is an equal distribution of force by the illustration of this person. What do you think? So if the gravitational force is way stronger than the force exerted by the person will be squashed to the ground. Or in the same way as that person will be in a different planet, or let's say this person goes to the moon, where the gravitational force is less. No? So may I ask that audio of those who are not muted, or I'll kick you in this class because it creates an interference. Again, ask those who are not muted to mute themselves. Jukon, mute your. So as with Maria Mercedes, can you mute? Thank you. Jok, you mute your audio, Jok. Okay, going back. So forces should be balanced. The force that is exerted by the first person and the force exerted by the gravity should be of a net force of 0. That net force of 0 illustrates the balance of forces, the balancing of forces. Otherwise, in the game of tug of war, if you're familiar with the tug of war, the time when we had the intramurals, when we had this rope and then we get to pull the rope to our team's end. If there is unbalanced force, then one team will win with the other. For example, if Team Blue gets to have a stronger force over Team Red, then Team Blue will win the game of tug of war. since there is unbalanced force exerted between two teams. But if both teams exerts equal forces upon pulling the rope in a game of tug of war, nobody will win the game. Perhaps the rope will be the one to surrender. The rope will snap, or the rope will just simply be stretched if that is a stretchable material made that made the rope. Okay, so that is law of inertia. We have here the second law generated by Newton. Newton's second law of motion pertains to the behavior of objects for which all forces are not balanced. In the previous law, all forces are balanced. No? If it's in motion, stays in motion. If it is at rest, stays at rest. But this time around, the second law of motion, which is the law of acceleration, states that the acceleration of an object is dependent upon two variables, the net force that acts on the object and the mass of the object. The greater the mass, the greater the force. Thus, faster the acceleration, the greater the force. Acceleration is dependent on force, but it is inversely proportional to acceleration. The heavier the object, the lesser the acceleration. The lighter the object, the greater the acceleration. So wait, I'll have to admit two people. John Patrick Lungat, is your connection, Patrick, not that good? Again, there's interference.
Ito, sir, my connection is not good.
Just turn off your audio and your video, but you may listen to the discussion. Para you won't be behind with the discussion. Same with Patrick and Maria Mercedes. Okay, so the second law of motion again states that the acceleration of an object is dependent on the two variables. Force is dependent on the object's mass. Force and mass. Again, acceleration is dependent on the force, net force, and the mass of an object. So with this, we can generate a formula for acceleration. We have the mathematical formula for acceleration is force, the net force, divided by the mass. This is where I get to express the words I just mentioned a while ago. Acceleration is directly proportional to force, but inversely to mass. Meaning to say, if the person gets to be heavy, the acceleration is less. I think that is understandable in its sense, where if a person, a heavy truck gets to accelerate at a constant rate, whereas a lighter truck can accelerate in a fast manner, no? Or if you cross multiply, you multiply mass to acceleration, by the act of cross multiplication, you'll end up with force equals, I think this one, force net equals mass, which represented by m. This is the mass, and acceleration, a, to represent acceleration. So this is the formula, F ma, force equals mass times acceleration. Clear? So there's an illustration of force here. Acceleration, the law of acceleration. Forces which are unbalanced depends on force and the object's mass with a formula. Force equals mass times acceleration, or A equals F over M. Look closely to the formula, class, because in the next slides to come, there is an example that pertains to finding the acceleration of an object given the force and its mass. Force, by the way, is expressed in Newton. Again, force is expressed in Newton. The unit of force is Newton. And Newton is equal to kilogram times kilogram mass meters per second squared. Yun. Okay. This is the unit of force, which is Newton, and Newton is kilogram times meters per second squared. This is the acceleration part, meters per second squared. The kilogram is the mass, the unit of force. So when you notice kilogram meter per second squared, you can just simply use capital N to represent the unit of force, which is Newton, taken from the proponent of the laws itself. Okay, so let's proceed. We have here an illustration. Sorry. We have here an illustration of, no, not necessarily. This is already the third law of motion. The third law of motion is going to tell us that if there is an action, there's always an equal or opposite reaction. Again, in every action, there's always that equal or opposite reaction. We call that the law of interaction. No? For example, someone whistles in the class. If there is that someone who whistles in the group, everyone reacts. So the action there is the whistling. The interaction is the looking of the classmates to the vicinity of the room. So that's the law of interaction. That's the third law of motion. So we have here an example. The wagon is going to be carried or pulled by the horse. The horse's action is directed towards the direction where he is facing. The wagon's action is directed to the other side of the to where the force of the horse is directed upon. So this one, this is the act of the horse here going there. The wagon goes there. Okay. So when you are the horse, you need to go there. The wagon pulls you to the other side. Equal forces generates no action. If the force exerted by the horse is equal to the force exerted by the wagon, then then there is no acceleration to happen. However, if the force of the horse is greater than the force of the wagon, then the wagon moves to the ground. And at the same time, the horse in itself is going to act with the ground force. The ground allows the force to stop the horse from its motion by the act of friction. But with the force of the horse in the ground as it pulls to that side, then there is that said action generated by the force of the feet of the horse in order for the horse to move to the direction where he intends to do so. That is now the application of the three laws of motion uh, by Newton. No? So if there is equal forces, no movement is done. If there is an unbalanced force, acceleration is done. And then everyone in this illustration interacts with one another. As you notice, you also sit on a chair in your places there. You are exerting force to the chair downwards. However, your chair exerted the same force equal to your force that is directed upwards. What do you think? So if the force exerted by the chair is lesser than your buttocks force, the force generated by your butt, your chair will be broken. Your chair will give up. Your chair will be dismantled. No? Otherwise, you need to buy another chair. So that is the law of interaction. If you look back to the different laws class, we ended up with this formula only, kinesia. We ended up with the formula only to the acceleration. So we're now going to focus our discussion to this formula as we deal with problems of acceleration. Considering now the application of this acceleration to the concept of force. So remember the formula F ma. Let's proceed with some examples. I think we have here examples. Okay, example number 1. Jerry pushes a 3.2 kilogram box with a 1.5 Newton of force. What is the resultant acceleration of what is the resultant acceleration? Again, Jerry pushes a 3.2 kilogram box with 1.5 Newton of force. What is the resultant acceleration? So to have that as a solution, we look back at what is the formula. The formula was F-ma or force equals mass times acceleration. But since we are looking for the acceleration, so we are going to derive the formula by dividing both sides by m. Divide both sides by letter m. Then the formula for acceleration would be force divided by mass. But I think this solution ends up with um, a substitution already. However, if you wish to know the the derivation, you go with force equals mass times acceleration. So divide both sides by mass. By dividing both sides by mass, you cancel the mass here. So acceleration is force divided by mass. Or you can have this in a triangle of formula. I don't know if you're familiar with this one in your mathematics before in the grade 7. The triangle of formula tells us that force is on top, mass and acceleration is in the bottom. So if the unknown is acceleration, your unit force is over mass. So the formula is force over mass. In the same manner as the unknown to be mass, if the mass is the unknown, then you have force over A or force divided by acceleration. Or to put it simply, the formulas for force, if the unknown is force, mass times acceleration. So this is the triangle of formula. Okay, so let's have that cleared. So in this solution class, the force, which is what is that? 1.5 newtons, and the mass, which is 3.2 kilograms, is already being substituted in the formula. So we have here 1.5 equals 3.2 times acceleration. And then after that, the 3.2 kilogram was divided to both sides of the equation. So we have here 3.2 kilograms to divide by 3.2, divide by 3.2. So cancel 3.2, leaving this expression 1.5 over 3.2. And I think you are very much familiar with mathematical solutions, no? So upon that illustration, you get to consider that the unit Newton can't be cancelled with the unit kilogram. So what was the unit of Newton equals to a while ago? Newton is kilogram per kilogram meter per second squared. So if we expand the unit of Newton to kilogram meter per second squared, we can now cancel the unit of kilogram. So our unit left will be meters per second squared. That's the unit of acceleration. So to proceed, we have now 1.5 divided by 3.2 is 0.47. And that is now the resultant acceleration of the force acted on the body, which is 3.2 kilograms. Question? So you understand example number 1? Not that much? Okay, going back. What law is this one? This is law of acceleration, di ba? The formula again for force is mass times acceleration. Again, the formula for force is mass times acceleration. This is the formula for force. Then, the force in the problem is 1.5 Newton. So you substitute 1.5 Newton to F, which is going to represent your force. Mass is 3.2 kilograms, so change the mass to 3.2 kilograms. That force and that mass will be our constant values that will determine the value of A. It's like finding the value of X. This time around, find the value of A. So divide both sides now by 3.2 since we don't need to have that value as a coefficient of A. So when we divide both sides by 3.2, we cancel this 3.2, leaving A equals 1.5 divided by 3.2. Use your calculator, divide 1.5 by 3.2, you end up with 0.47. However, how did we get mass meters per second squared? We dissect Newton to kilogram meter per second squared. That is the expansion of the unit Newton. Again, Newton is equal to kilogram dot meter per second squared. So we dissected the unit Newton to kilogram meter per second squared, and from there, we can eliminate now the unit of kilogram. Kilogram divided by kilogram, 1. So we ended up with a unit meters per second squared as our final unit, which we are going to use to partner with a quotient of 1.5 and 3.2. So the problem tells us the unknown to be acceleration, with the unit Newton to represent force, and with the unit kilogram to represent mass. Ergo, the formula is just simply what we're going to is our main basis of our solution. Or you can use the triangle formula again, and then if you wish to know the formula for acceleration, you just have to directly use the formula by dividing force, which is over mass. And this is what is that one. Ine is already this one. Force 1.5 Newton divided by mass 3.2. Question? Question? Yeah, are there clarifications that you need to address? Anyways, we have another example so that you'll be clarified. Okay? We have a chat from Gabriel. No, sir. Thank you, Gab. So we'll have the next example. In the next example, we have a different unknown. We have here a 1.12 kilogram ball rolls forward with a net acceleration of 1.11 meters per second squared. What is the net force on the ball? Again, we have this given. If you look at the given class, this pertains to the mass. Diba? The unit kilogram tells us that this is the mass. The unit meters per second squared tells us that this is the acceleration. Obviously, what is the unknown is presented in the problem. What is the net force on the ball? So to find the net force on the ball, we have to simply apply the formula again. What was the formula? Force equals mass times acceleration. So if you look at it, example number 1 and example number 2 always tells us the same formula. What is left for you to do? Substitute the given. You already have the formula there. You don't need to do anything but to substitute the given. If you look at the first example, the formula is still FMA. In the second example, the formula is again FMA. What does FMA stands for? Force is equal to the product of mass times acceleration. So simply multiply 1.2 kilogram by 1.11. You'll now get 1.24. Then the unit there would simply placing kilogram and meters per second squared side by side. And that is our unit, which we can equate to Newton. So our answer is 1.24 Newton. Question? Yes, Daniel.
Sir, is it okay, sir, na you'll answer 1.2024 then 32, sir?
Yeah, it's fine. It's just that I presented here the two decimal places. If you wish to copy all the decimal places, it's fine. Any other question? Thank you, Daniel, for the question. Who else wish to raise a question? None. No? Let's see. Okay.
Sir, can you do it again, sir?
Yeah. So let's put it this way. Go back to the given. Once you can clearly see the given in a particular setting, then analyze it well. So we have here the unit 1.2 kilogram. The 1.2 kilogram tells us that this is the mass, di ba? The mass. So if this is our mass, probably the other given should not be your mass. Looking closely to 1.11 meters per second squared, the unit meters per second squared tells us that this is our, what do you think so? Acceleration. Uh, if you don't really if you're not really so sure about the unit, go to the question, find the net force. In other words, the given should not be a force. It should not be this one as your force because this is unknown. So therefore, you go back to the formula, force equals mass times acceleration. And then, since you have the given 1.2 kilogram as your mass, so substitute it, 1.12 kilogram. After that, what is the mass? We have here 1.11. 1.11 meters per second squared. Finally, the 1.2 and the 1.11, multiply that, you'll get 1.24 as the final answer, or 1.2432 as said by Daniel. Then copy the unit, which is kilogram and meters per second squared. I just drew scribbles here, but you can just clearly picture out that solution here. Huh? And then after that, this unit is just simply telling us the expansion of Newton. In other words, your final answer is force equals 1.24 Newton. Provided all the given, it's just about to know the formula of the unknown. That's the beauty of this lesson class. You have all the given, locate the unknown, and then look for the formula. Okay. I hope we have. I hope we have another example. Yes. Yes. Rafael. Question, Rafael.
Sir,
Yes.
could we not use debug calculator, sir?
I that would be fine for me. You can use a calculator. The only concern here is not mathematical computation. It's to find the correct answer of the problem. So let mathematics do its deprivation of calculator to your lessons. But as of the moment, I wish you to give me the correct answer by, of course, you can use the calculator in your cell phone, you can use the calculator in your uh, house, which is anything that you can access upon gaining the efficiency, gaining the so-called the easiness in answering mathematical computation. But what is the use of that said calculator if you don't understand the problem, di ba? So that calculator is just simply a tool for you to finalize your correct answer. But for you to give me a correct answer, understand first the problem. In a way wherein it is easier on your part, that would be uh, your own ano na, discovery. How will you understand the problem properly? Discover it on your own. But I think the problem itself gives you already the clue. I think we have another example here. Maybe we can proceed to the next example. This is a seat work for everyone to answer. I wish everyone to do this for 2 minutes. We do this for 2 minutes. So let me read to you the problem. Luisa rolls a ball with 31 Newton of force. She observes that it has a constant linear acceleration of 2.1 meters per second. Question, what is the mass of the ball? This time around, the unknown is the mass. So you have to derive the formula for mass or substitute the given to the equation force equals mass times acceleration. 31 Newton is force, 2.1 meters per second squared is the acceleration. Time starts now. One minute. Ten seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Do you have answers with you ready? So let's have George Kent. May I know what's your answer, George Kent Dalalas?
10.76 kilograms, sir.
14.76 kilograms. So as with the others, 14.76 kilograms. Yes, Daniel, what's your answer?
65.1 kilograms.
65.1 kilograms. 14
It's
was the answer of,
14.76.
so we have two 14.76 and one not 14.76. So what is the unknown class? I'm not sure if the answer of Daniel is the correct answer, but probably the answer of George and the answer of uh, Gabriel is correct now. So let's try the solution. If you get the correct answer, this is the solution class. Force equals mass times acceleration. Since the force is given at 31 Newton and acceleration at 2.1, we are going to divide 2.1 to force, which is 31. Since the unknown mass is on the other side, right? So look at this one. If you, let's say, for what? This one. So this can't be just simply transposed there directly, but we need to divide it by the value 2.1. Jukon, warning Jukon, I will be going to exit your attendance if you play with your module. If you play with annotation. Stop playing with annotation. Okay, so we are going to divide both sides by 2.1. So that value 2.1 is the divisor of 31, this one, which is here. So 3.1 divided by 2.1 is 14.76. And you look at the unit, Newton, we converted Newton to kilogram meter per second squared. Therefore, we can now eliminate the unit of acceleration, leaving the unit of mass, which is kilogram, as the final unit for the unknown, which is mass. Okay, so who else gets to have the answer of 14.76?
14.76 kilograms.
Okay, yeah, that's the correct answer. 14.76 kilograms. So you use the you use the emoticon, or is that emoticon or emote raise hand if you are correct. Clarice already raised the hand. So as with Claire is also raising the hand. So Clarice and Claire, that's the here an answer. Avril is also correct. Victoria is correct. Perhaps I think the formula used by Daniel was multiplying 2.1 and 31, right? I think that's the solution of Daniel to end up with 64 or something. Okay, so question regarding the problems on forces. So what was the three laws of motion again? The law of inertia. What was the law of inertia? Let us recall. What was the law of inertia? The law of inertia, not Jude. Look, Jed. Look, Jed looks like uh, ano no, like a microphone in your with your head. Jude, look, Jed. What was law of inertia again? Without looking at your module. What was law of inertia? Don't look at your module. Sumangil ka ha. Do you have a module with you, Jed?
No, sir.
So you don't have a module then. By the way, for those who haven't had any modules with you guys right now, I will post the module in our Edmodo page in Science 8 so that you can access the online copy of it. Let's say, for example, you failed to see where you place your modules, or your brothers and sisters played with your modules. So you can now access a copy in the online. Okay. So law of inertia is Krisha. Let me ask Krisha. What was law of inertia again?
Uh, the resistance of an object
Yes, the resistance of an
to
object to motion.
change it. Yeah.
Or to put it simply,
Uh,
class, the law of thank you, Krisha. Perhaps you are choppy, so I cannot probably hear the complete sentence there. So the law of inertia states that an object at rest will always be at rest, and an object in motion will stay in motion unless there is an unbalanced force that acts on it. So that's the law of inertia. Okay. How about the law of acceleration, Shania? What was the law of acceleration?
What, sir?
What was again the law of acceleration?
More force means more acceleration, more mass means less acceleration.
Yes, that is correct. Also, to put it simply, in addition to the answer of Shania, if there is an unbalanced force that acts on an object, then acceleration is possible. Okay? If there is equal force, then there is no acceleration. But if there is an unbalanced force that acts on an object, then there is acceleration. How about Victoria for the third law? What did you understand of the third law? The law of interaction. Nikki was the nickname, right? Nikki? Okay, Nikki, what is your understanding about the law of interaction?
Which law, sir?
The third law, the third law. Anything that you
Oh,
can come up with the third law? Anything that you understand of the third law?
sorry, sir.
It's fine. Maybe we can call a friend. Let's try to call a friend. Thank you, Vicky. Thank you, Nikki. Let's
Thank you,
call
sir.
let's call a friend. Let's have someone raised a hand a while ago. Who was that? Oh, Erwin Boloran wants to help Nikki. Nikki, Erwin, what is the law of interaction? And Erwin
Sir.
is.
Sir.
Yeah, Erwin. Yes, Erwin.
Um, if an object exerts a force on another object, the second exerts an equal force on the for object.
Okay, that's it.
Yes.
Okay. So perhaps you are now going specific with your, now you're giving me an example, and that is correct, Erwin. No? So to clarify what Erwin's answer was, law of interaction states that if there is an action, no, pag may action, there's always a reaction. No? It could be an equal reaction, it could be an unequal reaction. That is why the law states that in every action, there's always an equal or opposite reaction. Okay? That is the law of interaction. Of course, the interaction comes with differences with forces. The differences in forces tells us that there is acceleration being done. If there is an equal forces, then there is no acceleration being done. Motion will be created even if the object is at rest. That is why we have the object at rest. Even if it's at rest, forces are acting upon them. Even if this laptop is on top of the shelf, but two forces are acting upon this laptop. The laptop's downward force and the table's upward force. Even if you simply lean on the wall, no? When you lean on the wall, the force on the wall exerts a force equal to the force you exerted to the wall. Do you think that the wall pushes you? The answer is a yes. Do you think that you also pushes the wall? The answer is a yes. If in case there is unbalanced force, if your force is way stronger than the force of the wall, then perhaps you might be the same as Samson, that you can topple down a very strong wall, huh? Or something like. So that is our three laws of motion. Again, the law of inertia, the law of acceleration, and the law of interaction. Questions? Questions? So in your module class, allow me to project the module for the time being. So in your module, every law comes with an activity, right? So if you look at it, the activity that follows in every law is generating you an understanding of every details that is located in that said law. For example, here, the first law. No? So you have here an activity pertaining to the first law. And what is the first law? Law of inertia. So these questions now goes back to the law of inertia. You can copy your answers from the notes here. You can search your answers in the internet, wherever you might find an answer. It's up to you. You are not limited to the notes I gave to you as your source of information. Now you are in an online class, feel free to maximize the online world to come up with a correct answer to these questions. Okay? But some of these questions are actually pertaining to the next law. You can refer it on the next law. Here, an example of problems that relates to the first law. So these are just but simple explanations. Do not give me a one paragraph explanation. A 1 to 2 sentences explanation will do, or 3 sentences. Okay? Question? None. So let's proceed to the second law. So this is the second law, and then activities to the second law. The beauty of the second law is that we are now going to have examples of computation here. Computations on, 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 on forces that act on the object. And then the third law is interaction. We have here the law of interaction. Still, we have here the problem about force. No? What is the net force of the car if you have a mass which is equal to 2569.6 kilogram with acceleration of 4.65. So most of these problems pertains to the world of motion, the laws of motion. Okay, you may chat your questions if your connection is not that clear, or you can raise your hand for your own questions. Questions, please. Daniel, question? None? Okay. So I believe two participants raised a hand. Shania, wish to raise a question? None? None. So if you have a question then, feel free to chat it to me through the Edmodo page or through the messenger. If, for example, you don't know answers on the module, feel free to contact or communicate with me from time to time. Anyhow, this Thursday, we're going to check your module and have answers to your module as well. Okay? So that will be all for today. Goodbye, class, and see you Thursday. Bye, everyone.